Hey everyone. So right now we're going to be looking at linear equations again, but this time it says write the slope-intercept form of the equation of each line given the slope and the y-intercept. So we're going to be focusing on writing linear equations, and this is the first set of instructions. Let's look at a few examples together. As you know, the slope-intercept form of the equation of a straight line is y equals to mx plus b. Pretty straightforward. We spoke earlier about the fact that m is our slope and b is our y-intercept. So this is pretty straightforward. So if I give you the slope, if I say m is equal to 3 and b is equal to -4, then all we're going to say here is y is equal to 3x minus 4, right? Or if we're going to go into, let's be a little bit more detailed. So y is equal to mx plus b. So we could say y is equal to mx plus b, right? And in this case, m is 3 as it's given to us, and b is -4. So this is basically a simple way of how we can write the slope-intercept form of the equation of a line given the slope m and the y-intercept b. Okay, right now we're going to be looking at a few examples of another set of instructions. This instruction says write the slope-intercept form of the equation of each line. We're going to look at a few examples, but before we do so, I just wanted to highlight something. The equation of a vertical line is the line x equals to a, where a is simply a constant, right? Wherever the line cuts the x-axis. Similarly, the equation of a horizontal line is the line y is equal to a, which is wherever the line cuts the y-axis. So that's just something we want to focus on for a second, all right? So an example would, we'll look at a few in a second actually. So here's a question that models this set of instructions that we're just looking at. Now, there are a few things that we want to do, right? Because we want to write the slope-intercept form, we need to look at the graph given here, and we need to highlight three main things. The first thing that we want to highlight is the slope, right? We call that m. The second thing we want to highlight is the y-intercept, b. But the slope has two things that we highlight. The first thing is whether it's positive or negative, and then the second thing is the rise over the run, okay? Now, when we're going to look at this, the first thing that we want to point out or identify is the y-intercept. That's the first thing we want to identify. So if we should look at this graph, the y-intercept is wherever this graph intersects the y-axis. So it intersects the y-axis at 3. So we can say that b is 3. Secondarily, we can also recognize that this line is sloping in the negative direction. So we know that we have a negative slope. And now, to find the actual rise over the run, we're going to find 2 points of intersection on a square here. So one point would be this point, one point would be this point. Those two are perfect. If I should look at that, I see that my line rises 1, 2 times, then it runs 3 times. So I can say my rise is 2 and my run is 3. In this case, that would mean that my slope is -2/3. Let's write this properly here. So my answer would be y is equal to mx plus b. So in this case, y would be equal to -2/3x plus 3. And that's typically how we do that. Here's an example of a vertical line. As you can see, this line intersects the y or the x-axis at 2. So we can say that the equation of this line is simply x is equal to 2. And now remember, a vertical line has a undefined slope, right? The slope of a vertical line is undefined, but it does have an equation. The equation is in the line x is equal to 2. Okay, perfect. We should look at this example here, identifying our y-intercept. As you can see, this is the answer, but let's look at this first. Our y-intercept here is -3, and 2 easy points here going up, here at -3 and here at this point here, -1 on the y-axis. We have a positive slope, so our rise is 2 and our run is 1, 2, 3, 4, 5. Hence we say y is equal to 2 over 5x minus 3. Here's another vertical line cutting the x-axis at -3, so we say x is equal to -3. Example. This one here has a negative slope, as you can see. Let's pick 2 points as well. This is 1 point. This is another point. We want to pick points that intersect, as we pointed out, intersects one of the edges of the square, right? So from here, we go 1, 2, 3. That's a rise of 3 and a run of 2, okay? Because it's a negative, we can say that the slope is negative 3, rise of 3, run of 2. Now with this example, the graph cut the y-axis at the origin. So we can say we don't have a y-intercept. Hence, we just have -3 over 2x. It would be +0, but we don't have to write that. So here's a set of instructions for our next objective. Write the point-slope form of the equation of the line through the given points. Let's look at a few examples together. All right, so as you can see here, point-slope form is y minus y1 is equal to m into x minus x1. Now, basically, to write the point-slope form, the only thing that we really need is our slope and a pair of coordinates, but we're given them here, right? And we can use any pair of coordinates or any coordinate, right, to be our y1 and or x1. So the most important thing that we need to find is our slope. And so because we have 2 points, we're going to find our slope by saying m is equal to, we're going to label this as x1, y1, x2, y2. And in labeling it, our slope is equal to y2, which is -2, minus y1, which is 3, divided by x2 minus x1, which is 1. Okay? This will leave us with -5 over 1, which is just -5. So that means that our m is just -5, right? Because we found the slope. Now, to write the point-slope form, we simply use any x and y coordinate. So let's say we use the first one. It's going to be that y minus y1, which is 3, is equal to m, which is -5, into x minus 1, right? We have to use the same set of coordinates, x1 and y1. So in this case, our formula says y1 goes first here, x1 goes second here. And this is your answer. So if you should look at this example, right, we want to find or write the slope or the point slope form of the equation of a line through these 2 points, right? So I labeled them here for you. I did this one already, so we're just going to look at it. I labeled them here for you as x1, y1, x2, y2. So these are our coordinates, right? And I'm going to use those to find the slope of the line. So remember, slope m is equal to y2, which I highlighted for you here, minus y1, which is -3, right here, divided by x2, which is 2, minus x1, which is negative 2, right there. If you notice, I use my parentheses carefully because that's going to... As you can see, I use my parentheses carefully, so that would actually indicate where this negative and that negative will become a positive here, and this negative and that negative will become a positive here, right? So this will become negative 4 plus 3 and 2 plus 2. So this will give us negative 1 divided by 4. So this is our slope. So now, given the point slope form, I already have what my slope is. Now I'm going to pick any one of these coordinates. I could pick this one, or I can pick this one. So I'm going to pick this one, and I'm going to replace y1 with negative 3 here, and I'm going to replace x1 with negative 2 here, right? And that will simplify to, well, these negatives will become a positive again, so that will simplify to y plus 3 is equal to negative 1/4 x plus 2. And we call this the point slope form of the equation of a line.